Okay, Assalamualaikum and good evening, everyone. Can you all hear me? Okay, thank you for responding. Okay, so welcome to our webinar session on SPSS, a beginner's guide to data analysis. So my name is Dr. Aklili and I will be your moderator for today's session. So we are thrilled to have you all here and appreciate you taking the time to join us. Okay, so before we get started, I will assume you are all interested to use this SPSS. Okay, so this SPSS is a powerful tool widely used for statistical analysis in research across various fields. So whether you are a student, a researcher, or a professional looking to enhance your data analysis skills, so this session is designed to provide you with a practical demonstration in using the SPSS. So it is my great pleasure to introduce our speaker for today, Dr. Nurhuda Ramli. Dr. Nurhuda obtained her PhD in Applied Statistics from University Science Malaysia. Her field of expertise include applied statistics, exploratory data analysis, computational statistics, time series, and statistical modeling in social science. So her research also focused on analysis of data quality, scaling assumptions, and reliability of research instrument, management, and criminology, as well as psychological modeling using decision theory and networks. She is also a member of SQS Statistical Consulting, providing data analysis to the Academic Affairs Department of UUM. Okay, so throughout this webinar, Dr. Huda will guide us through the basics of SPSS, from data entry and management to performing descriptive statistical analysis. So with her practical insights, will equip you with the essential skills to effectively use SPSS in your own project. So please feel free to post your questions in the chat box during the presentation, and we will have a Q&A session at the end of this session. So without further ado, I would like to invite, let's give a warm welcome to Dr. Nurul Huda, and Dr. Huda, the floor is yours. Are you ready, Dr. Huda? You can. Okay.
Okay, sorry. Assalamualaikum and salam sejahtera. Ya, boleh dengar ya suara saya sekarang?
Yes, loud and clear.
Yes. Okay, thank you. Thank you so much, Dr. Nur Akrili, for the brief introduction. Okay, regarding my academic background. Okay, so tonight I am sharing a webinar regarding the SPSS, a beginner's guide to data analysis. Okay, so actually, this is a very basic or a foundation to the using SPSS. Okay, so I would like to share my knowledge and also hope that at the end of this session, students will be able to navigate SPSS, learn how to click, how to run the analysis, and also how to interpret the output from the SPSS. Okay. And throughout this session, because this is informal webinar, so I'm going to mix somehow with English and also Bahasa Melayu for Malay students, okay, because some of them are using Bahasa Melayu for their thesis and also for their FYP project. So I'm going to mix around and also will elaborate some terms or some definition in Bahasa Melayu as well. Okay, so this is an introductory courses. This is an introductory course which cover the basic foundations and also features of SPSS, including data analysis technique, data entry, reporting findings, and also we also will guide you how to report the findings for the purpose of research and also academic purpose. Okay, and this is for the, like I mentioned before this, our target audience is the SPSS newbies or beginners, okay, which covers the basic statistical knowledge. And maybe many of you have attend advanced level in SPSS and also data analysis courses, but tonight we will cover for the introductory level, okay? And throughout this session, I will show step-by-step instructions using practice data set so that students will able to know how to navigate the SPSS steps, okay? And also we will focus on core functions of the common statistical analysis. And we are not really in depth in terms of research methodological aspects. Okay, for example, in terms of sampling method, numbers of sample size, assumptions of the statistical test. Okay, we will focus on the core functions and how to navigate SPSS. Okay, so let's start with a big question now. Okay, so how should I analyze my data? Okay, you collect your data. Okay, you do the pilot test, you do the real data collection, and also you have a data. Okay, so now it comes to the big question, how should you analyze your data? Okay, so actually it is depends on the nature of the data and what research questions that you want to answer. Okay, so in answer to this question, of course, you need to explore your data and also select the proper analysis. Okay, so students also might confusing whether the data is categorical or continuous data. And in terms of analysis, also there is a confusion between whether you want to measure the differences or you want to measure the relationship. Okay, so I am going to brief big steps in statistical analysis. Okay, so there will be 4 major steps. Okay, when involved in statistical analysis, the first one is you need to explore your data, meaning that you need to know what is your data definition. So this covers what is your data format, your variable type, and your values levels. Especially in SPSS, you will come across with this variable type, value levels, and so on. Okay, and also the quality of your data, meaning that how you address or how you cater your missing values, outliers, and so on. Okay, and moving to second step, how to analyze your data. Okay, so this involve selecting the right statistical test. Okay, so for your FYP project or for your academic research, usually we will start with descriptive statistics and also moving to the inferential statistics or even advanced statistical analysis. Okay, and after we select the right statistical test, we will run the analysis. Okay, and then after that, this is the important part, meaning that how you interpret your results. Okay, so this can be done by you have an understanding what is the key statistic, such as what is the p-value means, what is sig. Okay, when you running statistical analysis in SPSS, the output will have SIG. So what is SIG means? Okay, the confidence intervals and how this value means in your contextual framework. Okay, meaning that in your application of your study, how this p-values means, how the confidence intervals means. Okay, and last but not least is how to report your result. Okay, and this is important for you to clearly and concisely communicate the findings. Okay, rather than just copy paste the output to your thesis, okay, you need to really clearly and concisely write up your report so that the readers or the examiners will understand what are you going to achieve or what are you going to show the result of the statistical analysis. Okay, so in this webinar, I have these outlines. Okay, the first one, we will start with getting to know SPSS. Number 2 is data entry and manipulation. After that, we will go descriptive statistics, okay? And then we will see 3 common statistical types in inferential statistics. The first one is one-way ANOVA. Second is bivariate correlation. And the last one is simple linear regression. Okay, and last, we will open for the Q&A session. Okay, let's start with getting to know to SPSS. Okay, so what is SPSS? Okay, so it is a software package used for statistical analysis data and produced by SPSS Incorporation in 1960. Okay, so SPSS used to stand for Statistical Package for the Social Sciences. Okay, I remember during my time doing my first degree, yes, the terms for SPSS is actually stand for Statistical Package for Social Sciences, okay? Then later changed to Statistical Product and Service Solutions, and now is generally known as IBM SPSS Statistics, okay? And as you can see, actually, more than 53,500 papers indexed in Scopus from 2010 until 2019 has used SPSS for data analysis. And the trend of the SPSS use is increasing. Okay, as you can see here, so most of the subjects areas are medicine, social sciences, engineering, business management, accounting, biochemistry, and molecular biology are the top 5 subject areas. Okay, so please don't feel afraid to use SPSS. Okay, and please do not underestimate the use of SPSS, especially when you want to publish in the Scopus Index Journal. Okay. Okay, so there will be 3 main windows in SPSS. Okay, as you can see here. On the left side is the data window. Okay, the data window is for the data entry and also for the database. And normally the files, when you save the data window, we can have the .sav files. Okay. The second window is the output window. Okay, where the output of any SPSS sessions will be stored in this window, and we can save by .lst files. And the last one is the syntax window. Okay, where the syntax window, other than we use click and point and click interface, we also can write and also execute commands in SPSS, which can be stored in .spss files. Okay, so our focus or the main use of the windows in SPSS, usually students will use the data window and also output window. Okay, so this one is really quite straightforward, easy to use, and our focus of the webinar also will be these 2 critical windows of the SPSS. Okay, so we will explore how to navigate and utilize these windows, and also how to manage and also how to analyze your data. Okay. Okay, next, let's move to data entry and manipulation. Okay, so this is the interesting part here. Okay, so this is the data format in the data window. Okay, as you can see here, in the data format or in the data window here, we have 2 main tabs here, data view and variable view. Okay, so In formatting the data, okay, we can defining the data by assigning specific formats to the data in the SPSS. Okay, so like I mentioned before, we can view the data into the two ways: data view and also variable view. Okay, so this is the data view where the data is placed by cells, by row, okay, and by the column is the variables. Okay, here where the rows here is a single case of observation in your data set. Okay, for the data entry, you can manually type in your data and you can load from file. Okay, and also at the top of the data window is the key tabs where you can perform your tasks. Okay, and the column is your variables. Okay, now moving to the variable view. Okay, this is important so that students must know how to define each of the variable. Okay, so let's start with name. Okay, so in the variable view here, we have a list of variables. Okay, and for naming the variable, you must follow certain rules, such as you must start with letter, no space, and it also case sensitive. Okay, if you, for example, if you type age, capital A, it also will detect as the same small letter age. Okay, so please make sure that you will use different letters for each of the variable, and also avoid special characters for CS. For example, if you use hashtag, okay, alias, so please avoid special characters. Okay, second column is type of the variable. Okay, so we have two types. The first one is string and second one is numeric. For string is when you type in text data, and numeric is the numerical data. Okay. For the width, actually the width is the length or the maximum characters in the variable. Okay. For example, if your data has one value, so you can use 1, or maybe you can use maximum 2, okay, so that you will avoid type in error and also the outliers in your data set. Okay. Another important thing is label. Label means you can write your data, or you can write your variable name. Okay, and you can give the descriptive for the name. Okay, for example here, if for variable name, okay, I am using SM platform variable name here. SM platform is a short form of social media platform. Okay, so in the label, I can explain. So this variable is actually the most used social media platform. Okay. Another example, frequency SM. So it is actually the frequency of social media use. Okay, and you also can include units, or if you're using scale, okay, you can write the scale from minimum to maximum. This is just for your own reference so that you can confuse with other variable. Okay. Another important is values. Okay, values is a coded value of data point. Okay, for example, you can put 1 as male, second was female. Okay, and also for the columns here, it also this one shows the width of the variable column. Okay, so for example here, if you name here country, age group, so it will reflects your width of the name of the variable. Okay, and another important is the measure. Measure here refers to the level of measurement. Okay, meaning that either nominal, ordinal, or scale. Okay, so for the categorical variable, it can be either ordinal or nominal. Okay, and for the numerical variable, okay, you can use scale. Okay, and the last one is a rule. Okay, so the rule shows the function of variable. Okay, so if we have the independent variables, IV, so we can assign as input. Okay, if we have a dependent variable, we can assign as target. But however, this function or this setting does not directly affect most of the statistical analysis, okay? Because sometimes the independent variable also can be the dependent variable. And sometimes the variables can be in either IV or DB, okay? Okay, I am going to show you data manipulation after this. Okay, let me check. Okay, all right. So I'm going to show you the data manipulation here. Okay, this is the example that I have data. Okay, this data is, okay, I have 11 variables here. So this data actually regarding the cyberbullying, and we want to determine what are the factors that affect the cyberbullying. Okay, so I have a few of the variables. Okay, the country, age, gender, social media platform, frequency of social media use, daily social media usage and hours. I have anxiety level, stress level. Okay, for the stress level, I have two items, item 1 and item 2, and we have one dependent variable. Okay, so the data view can be like this. Okay, now for the data manipulation, we have two main data manipulation for the SPSS. The first one is the recruit. Okay, recruits mean we want to give the value for the one of the variables. Okay, for example here I have age. Okay, so as you can see here, for this data, the respondent are giving the exact number or the exact value of age. Okay, so now let's say we want to recode this age to the age groups. Okay, so what you can do is you can go to transform. Boleh nampak ke? Boleh nampak ya skrin saya? Okay.
Yes, we can.
Yes, alright. Okay. So okay. Okay, let's say I want to record this it can be record into same variable or record into different variable. Record into same variables meaning that you are replacing the original data to this variable. Okay, but if you want to record to different variable, meaning that you are creating another new variable and your original data will be transformed to the new variable. Okay, so for example, okay, I want to do age here. Okay, and my output variable, let's say I choose age group. Okay, then I can click change. So you can see from age, your new variable now will be age group. Okay, so all and if you all and new values. So all value, as you can see here, you have a range of age, right? So let's say you want to start with the first one. Sorry. If you want to make a range, for example, from 18 to 25, you want to code as first group, then add. Okay, so from 26 until 35 will be your new value will be second group, add, and then 36 until 45 will be your third group, and the last one is 46 until 55 will be your fourth group. Add. Okay, so you have these new settings here and continue. Okay, and now you can have in your new variable age group here. Okay, age group. So as you can see that you have the original data and you have a new coding for the age group. Okay, so why we do this? Because later in testing the differences, okay, we can use this age group for the testing of differences. Okay, so as you can see, you have decimals here. So here you can reduce the decimal here, H group as 0, so that you don't have any decimals in your data. Okay, boleh faham Alright. Okay, itu kalau kita buat record. Okay, another important is how we can compute. Okay, compute variables. Okay, for example, in order to run certain analysis, for example, correlation analysis. Okay, if you have more than 2 items, okay, you have more than 2 items that can be known or that can be regarded as your stress level. For example, here I have stress level 1 and stress level 2. So imagine that if you have more than two items here. Okay, more than 1 items lah sebab kita nak groupkan. Okay, for example, for stress level you have 4 items or somehow 5 items. Okay, so how are you going to group this, or you can compute this using transform compute variable. Okay, so the compute variable will calculate, okay, what is the arithmetic mean, median, standard deviation, and all of the mathematical function for you. Okay, so for example, okay, let's say, okay, for this one, you have to name the new variable first. Okay, let's say I have stress level. Okay, stress level is the mean of stress level 1 and stress level 2. Okay, so we go to transform compute variable. So go to the stress level as the target variable. Okay, so is equal to, so let's say you determine as an arithmetic. Okay, you can calculate, statistical. You want to calculate mean. Okay, so you can use this arrow so that the mean function will be appear here. So you can use stress level item 1, and second is the stress level 2. Okay, so if you have more than 2 items, okay, you can include all of the items here. Okay, so this one also will be there. Make sure you type in the correct name of the variable. Okay, let's try this. Okay, so that this one will be mean. Okay. Okay, all right. Now you can have your data here, stress level. So actually this is the mean of stress level 1 and stress level 2. So you don't need to calculate differently from Excel, okay, to calculate the mean. So you can calculate directly from here, and also you can get the new variable from this. Okay, again, if you want to reduce the decimals, 0. Okay. So this is the 2 types of the data manipulation. The first one is how you can recode the data, and another one is how you can compute a new variable. Okay, all right. So any questions so far? Later we will save during the Q&A. Okay, all right. Now after that we can move to analyze our data. Okay, let's begin with descriptive statistics. Okay. Okay, so normally when you reporting descriptive statistics, okay, you will report the frequency, meaning that accounts for each value for the variable. And also you can represent your data using charts. Okay. And another thing, you also can report the measure of the central tendency, meaning that either you will use mean, median to summarize your center, and also the dispersion, for example, the standard deviation or the variance, and also sometimes the range to quantify the spread of the data. Okay. So in order to navigate to the descriptive statistics, you can use the analyze tab, go to the descriptive, and you can see two menus here, frequency and also descriptive. Okay. Okay. So, okay, I will show you. Here is analyze. Okay, you can find here descriptive statistics, frequency, and also descriptive. Okay. So for the frequency, okay, you can choose which of the variable that you want to calculate. For example, let's say you want to determine the daily social media usage, and also maybe you want to find the most used social media platform. Okay, so you can click display frequency tables. For the statistic, you can determine what is the mean, and also for the dispersion, standard deviation. Okay, this is the two common measurement for reporting the descriptive statistics. Okay, so continue. For the charts, you also can use bar chart, okay, or maybe the pie chart. But if you have, let's say here, you have different types of the data. This one is in numerical, this one in categorical. So maybe you can use one by one, okay, so that you will not get confused with the charts. Okay, so for example, let's say I want to choose the most social media, so I want to display as a bar chart. Continue. Okay, for this you cannot get the mean and also standard deviation lah, because this one is not a continuous data. This is a category and vertical data. You just can have the charts for this data. Okay, so untick this. And also, okay, so you can have your output here. Okay, so as you can see here, the statistic n meaning that your number of the sample, okay, and you have the frequency here, okay, in terms of number, frequency, and also percent, and also cumulative percentage, and also the bar chart. Okay, again, you can utilize the charts function in the SPSS, okay, because many students, when they want to build charts, okay, they will use Microsoft Excel. Okay, actually you can also use from the SPSS. Okay, and if you double click the charts, okay, you can edit this. Okay, meaning that you can change the labels here, you can change the legend. Okay, and if you want to exclude the major line, also available. Okay, if you double click the functions here. Okay, so if you're done editing, just close. Okay, just close and it will go back to your output. Okay. Right. Okay, another thing for the descriptive statistic is the, let's see. Okay, so before we move to the normality test, I will show you again for the central tendency. If you have the continuous data, you can use analyze descriptive statistics, and also you can use frequencies. Okay, so for example, if you want to determine the daily social media usage, okay, so you can click here mean and also standard deviation, continue, and also, okay, you also can determine the charts. Okay, For the normality, I will show you after this. So yes, you can have here. So the mean is 3.535 and the standard deviation is 1.4235. Okay. And this one will give the exactly data points. So it will calculate how many respondents have 1 hour of daily social media usage. So 3 of them. Okay. 1.2 is 4. Okay. So this one will tell you the data. And okay. And this one is the histogram. Right. So, okay, next. Let's move to the normality test. Okay, so for the normality test, it is important for you to assess whether your data follow a normal distribution or not. Okay, so because most of the statistical analysis or statistical test will ask you to do the assumptions, which is one of them, your data must follows normal probability distribution. Okay, and how are you going to test the normality using SPSS? Either you can use the plots, okay, either histogram, QQ plot, or the PP plot. So for tonight, I'm going to show you how to test using histogram with the normal curve and also with the QQ plot. And the other one is the test of normality, okay? So for the test of normality, we have to test the Shapiro-Wilk and also the Kolmogorov-Smirnov. For the Shapiro-Wilk is useful when you have small sample size, meaning that less than 50 samples, then you can use the result from the Shapiro-Wilk. And for the Kolmogorov, you will use when you have a larger sample size, meaning that you have more than 50 samples, okay? So in order to perform this, you can go to the Analyze tab, go to the Descriptive, you can look at the frequency and also explore, okay? So let's try this. Okay, go to Analyze, Frequency, and also Explore. Okay, so for the Explore, okay, let's say you want to test whether your daily social media usage has a normal distribution or not. Okay, you can click with the this one if you want to explore more. For the plots, okay, you can test here. Normality plots with test, okay, means that it will show you some of the normality plots such as PP plot, QQ plot, okay, and also you can also see the stem and leaf and also histogram, okay. For example, I just want histogram. Continue. Okay, so we want our outcome will be both statistics and also plot. Okay, let's try. Then you can have the descriptive, meaning that it will show you the mean. Okay, same here, the mean and also some of the measurement. Okay, here, the test of the normality, as you can see here. Okay, for the Kolmogorov and also Shapiro-Wilk, you can use either one. Okay, so for my cases, I will use Kolmogorov Smirnov because my sample size is more than 50. Okay, so the daily social media usage, as you can see, it is a significant, meaning that it follows a normal distribution. Okay. And here you also have the QQ plot and also QQ plot, meaning that the observed value is equal to the expected value. Okay, so if you get the line here, meaning that the data for the observed is somehow equal to the expected normal, so it follows a normal distribution. Okay. Okay, another one you can do. Sorry, analyze. Okay, you also can look at the frequency just now, where the charts, you can also take histogram and show normal curve on histogram. So this one also, you can get the shape of the normal distribution. Okay, so you have a bell curve here, and you can tell that this data also follows a normal distribution. Okay, so now, okay, that is regarding the descriptive statistics. Okay, now let's move to the inferential statistics techniques. Okay, so I have listed 3 common analysis for the FYP students, okay? For the test of the difference, I choose one-way ANOVA to determine the relationship by variate correlation and also to model the variables or to model the data using the simple linear regression, okay? So let's start with one-way ANOVA. Okay? But before that, let's recap a few methodological or statistical modeling that you have learned before this. Okay, so inferential statistics involves the use of a sample to estimate some characteristics in a large population and to test a research hypothesis about a given population. Okay, so I believe that most of you have learned about the inferential statistics. Okay, meaning that the aim here is to estimate the characteristic of the populations, meaning that we want to infer what is the characteristic of the population and also to test our research hypothesis, meaning that to give information about our population. Okay, using the sample, we want to give information about the population. Okay, so maybe most of you have learned about many statistical analysis in your research methodology or in your statistical modeling subjects, okay? But in this webinar, I will be going to focus on three most common analysis for the FYP students, okay? Meaning that for the undergraduate level students, okay? So the first one, okay, and for these three analysis, it is under the parametric test, meaning that when we test that our data follow a normal distribution, then we can use this test. Okay, so if our data doesn't follow a normal distribution, we can use a non-parametric test. Or the other option is you can normalize the data first, meaning that you can transform the data and you can get the data in the normal distribution, then you can use the parametric test. The either option can be useful. Okay. So the first one is one-way ANOVA. Okay, meaning that we have groups and we want to determine the differences of the groups. Okay. So the one-way ANOVA is useful when you want to test the difference of 3 or more observed means. And the samples that you are going to test is the independent samples, meaning that they are not related to each other. Okay, they are not paired samples. For example, if you have the before-after samples, so you can use the one-way ANOVA. Okay, the samples must be independent to each other. Okay. Secondly, we want to assess the association between two samples, meaning that we want to test what is the bivariate correlation between two samples, or also you can use for to test between two variables. Okay. And the last one, I will focus on simple linear regression, okay, not the multiple linear regression, because due to the time constraint and also lots of explanation if we are using the multiple linear regression. So I will show you how to use the simple linear regression, okay? So the simple linear regression, or we know as SLR, use one or more for the simple linear regressions, it should be one explanatory variables only. Okay, meaning that you have one independent variables to predict the outcome of a response variable, meaning that one dependent variable. Okay, for simple linear regression, one IV, one DP. Okay. Okay, so this is some of the statistical techniques. Okay, this one I have from Julie Palan. Okay, so she has she produced many SPSS survival manual textbook. Okay, you can search in the Google Scholar. Okay, so I think for now it has 6th edition, I think. Okay, so the latest edition. So this one this one is the table that can guide you how to choose the statistical technique. Okay, what is the purpose? And what is the example of the research questions that you want to answer? What is the parametric statistics? And what is the alternative, meaning that use the non-parametric? Okay. What is the IV? What is the DV? And also the essential features that you need to consider when you run the statistical techniques. Okay. So actually it is good readings, okay, so that you can recap what are the statistical technique, what is the related example, related research questions, what is the independent variables, and so on. Okay. This one is for the exploring the relationships. Okay, as you can see, we can use Pearson correlation, multiple regression, factor analysis. Okay, and another one is comparing groups. Okay, where we can use the t-test, one-way ANOVA, one-way repeated measure ANOVA, okay, two-way ANOVA, mix between ANOVA. So you have example of the parametric statistics that you can use to answer your related research questions, okay? And she also guided you how to choose the independent and also dependent variables, okay? So it is really a good book to study using the regarding the SPSS. Okay, so let's move to our one-way ANOVA. Okay, so what is one-way ANOVA or one-way analysis of variance? So it is a technique I use when you want to compare the mean difference of 3 or more groups. If you want to compare two groups, you will use the t-test. Okay, for example, if you want to compare gender, male and female, so it will be independent t-test. Okay, but for tonight, I will focus on the one-way ANOVA. Okay. So the requirement to use the one-way ANOVA, you must have one categorical IV, and the categorical in SPSS, you must set as numeric type, okay? And one continuous DB. And the example research hypothesis that you need to test is there is a difference in the means of cyberbullying among different age groups, okay? Since my data is regarding the cyberbullying, so I want to test whether there is a difference in the means of cyberbullying among different age groups, okay? So for the execution, you can click Analyze tab, go to Compare Means, and you can see one-way ANOVA here. Okay. Okay, so let's see. All right. So from this, let's check first. I want to test the age group here. This is my category age group. And you must have the type of numeric. Okay, numeric. And let's see, let's say we want to test for the this variable. Okay, cyberbully here. Okay, so this one. I can go to Analyze. Go to Compare Means, click one-way ANOVA. Okay, if you have data set, okay, you also can test at your own data set. Okay, kalau memang dah ada SPSS, boleh buat sama-sama lah. Okay, kita boleh tengok. Okay, so for the one-way ANOVA, okay, so dependent list, let's say I want the cyberbully as my dependent variable. Okay, and the factor as age group. Okay, go to factor here. Okay, this one, if you need any additional analysis, then you can click. Okay, for example, you want to compare which groups are different. Okay, for example, here you can use a contrast. But if you don't need extra analysis, so you don't have to worry. Okay, this one, actually this one, if you want to test whether group 1 is different to group 2 or group 3 different to group 4 and so on. But if you do not need the analysis, so you can just ignore. Okay, so just click OK, and you can have one table of this. Okay, for the ANOVA. So it will have the sum of square, meaning that the sources of the variances between groups and also within group. Okay. For the result, the main result is you will see the F value here. F 0.923 and also SIG. SIG means significant. Okay. If your value here is less than your P value, is your you see here is your p-value, sorry. So if the p-value here, 0.43, is less than your alpha, let's say you choose as 0.05, so your result is not significant, okay, because it has a value more than 0.05, okay. So how to report this? Okay, you have this output, you have this result, and how to report this, okay, in your thesis or in your report. So the best practice is, okay, you do not have to copy the table. Okay, most of the students, they will copy this table, exactly the table to their thesis. Okay, so what you can do is, for reporting, okay, from SPSS output here, you build your new table. Okay, you build your new table. Okay, for example here, you can list down factors. For example, this one regarding the age group here. Okay, you have 4 age groups here, and you also the value of 95% confidence interval and p-value. P-value is from the SIG. This is your p-value. Okay, so if the SIG value less than or equal to 0.05, then there is a significant difference among the means on your DB. Okay, and also you can include in your table other factors, for example, gender, nationality, and so on. Okay, so that you can optimize the space of your thesis, and also in terms of writing also will be easy. Okay, so for example here, this is how you can write up in your thesis. Okay, so the result of the one-way ANOVA indicated that there were no significant differences in the experiences of cyberbullying among the groups, and you state the p-value more than 0.05. Thus, we fail to reject the null hypothesis. And this suggests that the age group does not have a statistically significant effect on cyberbullying. So, actually, the examiner wants you to know how to read your findings. Okay, not just copy paste the answer, but also you must know how to storytelling your answer. Okay, what does this mean, and how this value means in your context. For example, in my context is the cyberbullying among the groups. Okay, so that you need to really concisely write and also explain your research finding. Okay, not that too long, but just will be meaningful. Okay, to understand and also to answer the research questions. Okay. Okay, that one is one-way ANOVA. Next, we go to the bivariate correlation. Okay, so for the bivariate correlation, bivariate correlation techniques are used when you want to measure association or relationships between two continuous variables. Okay, remember, your variables must be continuous. Okay, either IV or the DV, so it must be continuous, then you can use the bivariate correlation. Okay, so the example of research hypothesis that use the bivariate correlation is there is an association between social media usage, so my social media usage is in continuous, and experiences of cyberbullying also in the continuous. This one in the scale of 1 to 5. Okay, so both are continuous. So we can do the bivariate correlation. Okay, so we can do this by using the analyze style. Go to correlate, and you can see here bivariate. Okay, so let's see social media and also cyberbullying. Okay, so this is my data. I want to do the correlate bivariate. Okay, so in this bivariate correlations, okay, you can choose your variables. For example, I choose daily social media usage and also cyberbullying. Okay. Okay, so you also can enter different variables. Okay, it can run at the same times. For example, I can move anxiety level. Okay, so that it will calculate the bivariate correlation between these three variables. Okay, So for the correlation coefficients, so since we are using the parametric test, our data are normally distributed, so we can use Pearson and we can test for the two-tail or one-tail, okay? Most of the case we use the two-tail. One-tail is, one-tail if we know the nature of the relationship. Okay, meaning that if we know somehow there is a positive relationship between the data, then we can choose the one-tail test, okay? We choose flat significant correlations. Again, if you do not any additional analysis regarding the correlation, so you can ignore this menu, okay? So just click OK, then you can have the correlations here. Okay, as you can see here, it will give you the matrix correlation. Okay, so it will show you the correlation between daily social media and also cyberbullying is the Pearson correlation is 0.074. This is your R value. Okay, and your P value is 0.299. Okay, for the daily social media versus anxiety, the correlation, the Pearson correlation is R equal to 0.176 and the P value is 0.15. Okay, so how to report this? Again, you do not have to copy this table in your thesis. Okay, you don't have to copy this table. So what can you do is you can display. Okay, this is one of the example. How you can display your bivariate correlation. Okay, so the measures is, for example, here I put here all of the variables. Okay, this one can be read as the daily social media usage and anxiety level is 0.381. Daily social media usage and cyberbullying is 0.416. And 0.76 is anxiety level with cyberbullying. Okay, you can use this format as well. So for your reporting, okay, okay, this is example. You can use at your own words. Okay, I'm just giving the guidelines how you can report, meaning that how you want to include your important findings in your sentence. Okay. Okay, so the analysis reveals significant relationships between daily social media usage and anxiety levels. So you need to give, you say that there is a significant relationship, so you need to give the proof. So we have the R 0.381 and also the P value here. P value is less than 0.05, so it is a significant. And then between social media usage and experiences of cyberbullying, R equal to 0.416 and also P value also less than 0.05, meaning that you are giving the R between those two bivariate correlations, okay? And also another one as well as anxiety levels and also experiences of cyberbullying, meaning that R is 0.76 and also P less than 0.05, okay? So this is straightforward how to report your findings, okay? Meaning that you need to determine which one is significant, or if you do not have any significant relationship, also you can report in your thesis, okay? If you do not have any significant relationships, okay? And maybe in the next chapter, you can give justification and maybe you can do a discussion why you cannot have the significant relationships. Okay, maybe with support from other previous findings, previous journals, in the nature, in the application, in the contextual study. So there will be no significant relationships is reported. Okay, so it depends on how you will elaborate your findings. Okay, so I'm showing you the guideline, how to from the value here, okay, what does this mean? Okay, this is your correlation value R and P is the sig value here, 0.01 here, and how you can use this information in your sentence, okay? All right, so that is the correlation. So I think this one for the last one, simple linear regression. Okay, for the simple linear regression, Okay, so the simple linear regression techniques are used to examine the linear relationship between two variables. Sorry. Okay. The linear relationship between two variables and to predict the value of one variable, meaning that you want to predict the dependent variable based on the value of another variable, meaning that based on the independent variable. Okay. So if you are using the multiple linear regression, MLR, so meaning that you want to examine the linear relationship between more than one independent variable to predict the one dependent variable. Okay, but for this session, I would like to focus for the simple linear regressions only. Okay, and the example of research hypothesis for you to use the simple linear regression is, for example, here, daily social media usage can predict the likelihood of experiencing cyberbullying. Okay, or sometimes you can also use there is a relationship between daily social media usage and experiencing of cyberbullying. Okay, that is how you can use or how you can formulate your research hypothesis. Okay, so in order to run the SLR, you can go to analyze, go to regression, and also click linear. Okay, so let's go. Let's say here. Okay, go to analyze, go to regression and linear. Okay, so click here. Okay, for example here, I have dependent is the cyberbullying. So click the arrow for the dependent. So independent, okay, let's say I have the daily social media usage as my independent. Okay, and also I have the statistics here. If I want to calculate, for example here, you want to determine the estimates and also the confidence interval, you can take here. Also for the model fit, meaning that you just have the R-square value. Okay. Continue. Okay, I will explain you. Okay, this one for the residuals. We are not testing the residuals tonight. Okay, continue. And let's just click OK. Okay, so for the regression, you will have a few tables here. Okay, you will have a few tables here. Okay, the first one is the method of you enter the variables. Okay, we use enter, meaning that we are entering the variable one by one. Okay, especially if you use the multiple linear regression, you can use other method as well. Okay, either enter or also backwise. Okay, and then the model summary, this one will gives you the value of R square. Okay, I'll show you what is the meaning of this one. This one also will have you the overall model fit using the ANOVA. Okay, meaning that as you can see here, we have the F value 1.083 and also the significant value 0.299. And also from this coefficients table, we can have the unstandardized beta. Okay, this is our unstandardized beta, the standard error, and also standardized coefficient or standardized beta. We also have the T, significant value, and also confidence level for the beta. Okay, so I will show you the important key statistics for simple linear regression. Okay, the key statistic that summarize the model's performance and the relationship between variables. Okay, we can use in terms of goodness of model. It is important to you to see the R-squared value. Okay, R-squared value meaning it indicates the proportion of variance in the DV explained by the IV. Okay, if you have more than one IV, so by the IBS lah. Okay, so and also the F statistic. F statistic is to test the overall significance of the regression model. Okay, this is one from, we get this value from the ANOVA table just now. And also another key statistic is to determine the strength of influence of independent variables. So you can determine by using the beta coefficient. Okay, as you can see that we have the beta standardized value and also unstandardized. Okay, so indicates the slope of the regression line representing the change of the dV for a 1 unit change in the IV. Okay, and beta coefficient can be positive or negative. Okay, meaning that if you have a positive value, meaning that the change in the dV, there will be positive value, meaning that 1 unit change in the IV will lead to increment in dV, and if you have negative value, so 1 unit change in the IV will lead to the decrement in the dV. Okay, and you also have the p-value, which indicates the statistical significance of each of the IV. Okay, if you have more than one IV, so you can see the p-value of each of the IVs. Okay, and for the linear regression, of course, you must check for the assumptions. Okay, same goes to the multiple linear regression. It is important for you to do the assumption checks. Okay, this includes the linearity, independence of error, normality of errors, and also equal variance assumptions. Okay, so but we are not covered in this webinar because of the time constraint and also lots of technical interpretation and also aspects to see the assumptions check for the SLR. But for the students, yes, you must test this assumption first before you can run to the simple linear regression. Okay. Okay. So as you can see here, okay, in order to report the simple linear regression, okay, as you can see here, you don't have to copy all these 3 tables in your report. Okay, you don't have to copy all these 3 tables. Okay, the important key statistics that I mentioned before, for example, the R-square value, okay, R-square or the adjusted R-square. R-square is the proportion of the variance in the dV explained by the IV. Okay, we use the adjusted R-square when we have more than 1 models in predicting dV. Okay, then we can use the adjusted R-square. So if we have more than 1 model, so we can compare models with different predictors and we can use the adjusted R-square. But since I am using simple linear regression, I just have 1 model, so I am using R-square value. Okay, and also the important here from the ANOVA is the F shows that the model is significant, meaning that the IV is significantly predicting the dV, and also the coefficients, meaning that the magnitude of the relationships can be explained by the beta coefficients. Okay, so as you can see here, okay, so for the coefficient, we are using the unstandardized coefficient. Okay, unstandardized coefficient, because we are using the value here is in the natural unit of the daily social media usage. Okay, not in meaning that the daily social media usage, meaning that in hours. So the unstandardized coefficient, the value here is obtained using the unit hours. Okay, different to the standardized coefficient where we standardize the values of other variables as well. So for elaborating or interpretation, we will use the unstandardized coefficient. Okay, and for the t value of this variable, okay, and the p value here, it is a significant, and also the r square. Okay, so r square, as you can see here, 0.173. Or if you change the percentage, will be 17.3%. Okay, so using these statistics here, you can write in 1 sentence. Okay, for example, daily social media usage was found to have a statistically significant association with the cyberbullying. Okay, you include the important statistics here. The t is 0.6446. Okay, the p-value is less than 0.05, and the beta coefficient is positive 0.396. Okay, explaining approximately 17.2% of the variance in the cyberbullying behavior. Okay, so as you can see here, For the simple linear regression, you do not have to report so many things, just enough for you to address the important result from the key statistics. Okay. Of course, if you're using the multiple linear regression, you need to have more important key statistics here, and also more assumptions. Okay, for example, in terms of the multicollinearity, the error of the estimates, okay, the standardized residuals and so on, the correlation of the residuals and so on. So you need to check all of the assumptions, then you can report your results. Okay. Okay. Okay, so I think that's all for tonight. Okay, that's all for the sessions. Okay, so as in conclusions, we really hope that this session has equipped you with the skills to confidently navigate the SPSS, conduct various statistical analysis, and also you can effectively report your findings. Okay, and remember, the data world is your oyster. Go forth and analyze. Okay. Okay, so I also listing one of the reference that I cite in my webinar today. I am going to show you. Okay, the last one. Okay, I am using this. Okay, this one sebenarnya terpulang pada pelajar nak beli kita kan, especially for Malay students. Actually, I have my colleague that use this write this book actually. Okay, boleh nampak tak saya? Okay, boleh nampak tak?
Yes, but very clear.
Very clear. All right, thank you. Thank you.
Dr. Uja, can you assign Dr. Okleli as a co-host?
Oh, okay. Sorry. How to assign this? Can you?
Okay, can you you need to select her name and then right click.
See, right click.
Yeah.
Ni sekejap ya. Okay, and then right click and then change role, make co-host. Is it?
Exactly, correct.
Right. Thank you so much. Okay. Okay, so I am sharing this book. Okay, this is actually my colleague, Dr. Syamshurita Sharif from UUM. So she has write this book, Asas Statistik, langkah demi langkah cara menggunakan SPSS. Okay, so especially for Malay students who really afraid, sangat takut nak guna SPSS, sangat takut nak baca dia punya output. So you can use this. Okay, I also doing this book. Okay, for my students. Okay. So to supervise my students. So as you can see here, how to navigate the SPSS, and it also has a view like about the how to penyediaan soal selidik and so on. Okay, kaedah persampalan. Okay, so many things, and also how to navigate the SPSS as well. Also here. Okay, and also okay. So especially for the multiple linear regression, okay? Okay, you can test for the assumptions and how to read here. Okay, how to read the value here and how to click and select the variables and so on. Okay, so if you want to get this book, okay, you can contact me. Okay, I'm just helping. Okay, so that students can benefit this book. Okay, because it is, I think, not many SPSS book in Bahasa Melayu. Okay, so maybe you can use this for your own reference. All right. So I think that's all for me. Yes, I think that's all for me now. Thank you so much for your time. Terima kasih.
Okay,
I pass
thank
to
you,
Dr.
Doctor.
Lily. Yeah.
All right. Okay, thank you, Dr. Nurhuda, for your insightful and informative presentation. So we will continue with the Q&A session. There are quite a lot of questions in the chat box, as you can see. So I will randomly pick some of the questions here. Okay,
So
and
many
you can
questions.
also unmute yourself if you want to ask the question. Okay, I will start with the first one, Doctor.
Okay.
Okay,
Silakan.
okay. If the student want to collect data on the preferences.
Sorry, you want to collect
Okay,
data?
if the student, okay, collecting data on the preferences of the respondents in designing a new product, is it recommended to use SPSS or the Smart PLS? I
If
think
the
Smart
student meaning
PLS
that,
is another software.
oh, okay, yes, partially squared PLS, okay.
Yes, that one.
Okay, I would suggest that you can use SPSS first for the okay, for the actually for the data analysis. Okay, we have two types, the EFA and CFA. EFA is explanatory factor analysis, where you can explore your data before you can identify any relationships or any association between the variables. Okay, and confirmatory factor analysis is the analysis that you conduct after you found relationships. Okay, especially the CFA is used the factor analysis. Okay, I think, yeah, factor analysis. So you can explore using the SPSS, and if you have the navigation to run in the PLS also, you can run in the PLS. Okay, because last time when we have talked with Prof. Madia Dr. Faiz, okay, so there is advantage and also disadvantage that you can use. It depends on your nature of the data lah. Okay, if you use SPSS and also PLS. Okay, PLS is more powerful, as you can see, that more powerful software, because it can determine the relationship between the mediator variable as well. Okay, instead of IV and DV, you also can determine the relationship between the mediator variable, meaning that when you introduce a new variable in your theory, okay, you can use the PLS. Okay, and another thing that for the PLS, you don't have to calculate for the compute variable. Remember that I am showing you how to get the mean of two variables, stress variable 1, stress variable 2. So for the PLS, you don't have to calculate the to calculate the mean value of the variables. Okay, so the PLS will automatically run the analysis so that you don't lose any information. Okay, from the each of the items.
Okay,
I
another
hope that,
question.
yeah, I hope that answers you.
Okay.
Okay.
Okay, how to analyze the mediating variables in SPSS? And
Okay.
also, can you show how to test the normality for the Likert scale?
Okay. I am not really sure how to how to run the mediator variable using the SPSS, because like I said, okay, I am using the PLS. Okay, if we have another mediator variable, okay, for SPSS, I'm sorry, I am not really familiar. For the SPSS, it's just like I mentioned before. For the FYP students, for the undergraduate, I think SPSS is enough. Okay, meaning that it is sufficient for you to run the basic analysis. If you have advanced level, so you can use the PLS or the smart PLS. Okay. And then how to run normality for the Likert scale. Likert scale actually it is a long debatable issues. Okay, some of the social research scholars also say that Likert scale is a continuous data, but some of the mathematical or statistical side say it is a not continuous data because it is ordinal or categorical data. Okay, so but most of the article published either in Scopus journal or not, okay, it is a common or it is a nature for the social science field to use Likert scale as their continuous data. Okay, so saya lebih suka meraihkan lah sebenarnya antara kedua-dua nature ni. So tak ada salah, tak ada yang betul, okay, as long as we have a strong justification so that we can use Likert scale as a continuous measurement, so that we can use other parametric tests and also to test for the normality. To test for the nullability, you can refer to my slides before. Okay, we can using charts, the QQ plot, PP plot, histogram, or also we have the normality test. Okay.
Okay, thank you, Huda, for your explanation. Okay, we move on to another question. The third, can we use the SPSS to do the exploratory factor analysis in order to find the factors
Factor
from
loading.
the questionnaire? Is
Okay.
it recommended to use SPSS?
Like I mentioned before, saya tak pernah guna SPSS untuk running EFA. Okay, before this I use EFA. Okay, so I think if you explore, maybe the current version you can running the factor analysis. Okay. Other than factor analysis, actually it is compatible if you run the correlation. Also same, okay? Because the factor analysis also based on the correlation, meaning that you want to determine the strength of the relationship between the items, okay? But for the factor analysis, last time I used the PLS. I think that one will be more suitable because it will determine the factor loading and also have the features to remove the lower loading of the factor and also run another factor analysis. Okay. If mungkin kita boleh buat survey lah, kalau ramai yang setuju, maybe next kita boleh buat factor analysis pula ke kan. But last time bila saya attend Prof Ramayah punya workshop pun untuk higher level analysis such as factor analysis, mediator, moderator variable and so on, we test using the PLS. Okay, we test using the PLS. That one I think more suitable lah. Okay.
Okay, another question for you. Okay, can SPSS do analysis on the open-ended question from the questionnaire?
Oh.
For example, from respondents' opinion.
Oh.
Can SPSS do that?
I am not sure, but from what I know that it is a qualitative data, right? Qualitative data means you can use different software, for example, Atlas-T or somewhere else lah, anything else lah untuk qualitative data, okay? Because SPSS, even though you label the data as string, meaning that your data in text, but the analysis is still in using the numerical value of the data. Okay, for example, if you type in gender, MALE, FE, MALE, even though the data type is in text, but the analysis still using the numerical value of the data. Okay, we calculate the mean, the standard deviation, and so on. I think for the qualitative data, open-ended question, it will be more suitable using other qualitative software lah, macam Atlas-T and so on.
Okay, I hope that answer the question. Okay, another question for you. Okay, does multiple regression analysis can use the same step as you show for the simple linear regression just now?
Yes, you can use the same steps, okay? But for the multiple linear regression, like I said, you can move all the independent variables at one time, okay? That one using the enter method, or you can move one by one, okay? For the multiple linear regression, there will be more models, okay? You want to test the first model, for example, consisting of 2 variables only. Second model consists of 3 variables only, and you might want to see how the significant value changes as you enter the new variables in the model, okay? And after that, you need to test the assumptions of the multiple linear regression, for example, the multicollinearity, the heteroscedasticity, and so on, okay? For the multiple, also, it's quite more technical and also quite a long explanation if you want to show in this webinar. Okay. Maybe we can have another session also for the multiple regression analysis. Okay. Because this one is just want you to know how to navigate to the SPSS using the simple linear regression and also few statistical method for the FYP students.
Okay, I think okay, last question for you.
Okay.
Okay, is it necessary for us to do the standard error for our research?
Is it necessary for us to do standard error? Standard error in terms of what? In terms of variable or in terms of analysis?
I think in terms
If
of
the analysis actually it depends. Sometimes it is also important for you to report the standard error value. Okay, it is depends on the nature of your data and also the analysis. Okay, also refer to the previous journals or previous articles. Okay, if for your context it is normal for them to report your standard error, so you have to report the standard error. Okay, most of the, for example, if you do the cross-tag study or the, for example, the chi-square, I think you don't, some analysis do not have to report the standard error.
okay. I think there are other many questions that are not answered and we are running out of time now.
Yeah. Sebenarnya banyak
Dr.
soalan
Huda, can you
pasal
select? Yeah.
research
select
method
some-
sebenarnya. Banyak soalan tentang research method actually.
Okay, Dr. Huda, can you select some of the questions that you want to answer from the chat box?
Ya, sekejap saya tengok. So, sangat banyak ya soalan. Wait, there's a difference on area. Research assessment. This one have respondents. Okay. Okay, I have one question here from Nakib. If the question is based on different zoning area, for example, the research area has 6 zoning, a few zoning have around 40 respondents, while other zoning have around 70 respondents, meaning that you do not have the same or equal sample size for each of your zone, right? Okay. So yes, you can run in the SPSS, okay? Most of the analysis, for example, t-test, ANOVA, correlation, and so on, it doesn't fit to the assumptions your sample size must be equal for each of the groups. No. Okay, you still can run using the SPSS, even you have unequal sample size. Okay. SPSS or PLS better, that one also, I have answered my opinion. Okay, if you want to go for a higher level of analysis, you can go to PLS. Okay.
Okay.
Okay, if I have more than 5 IV, and 2DV, it is advisable to make use of SPSS or PLS. Depends on analysis that you choose. Okay. For SPSS also, we have analysis of 2DV, okay, two-way ANOVA, okay, and PLS also. So it depends on your analysis or the statistical methods that you want to choose, okay. Then you can use SPSS and also PLS, okay? Like I mentioned earlier, okay, do not, I also have this kind of thought actually, okay? So when you use SPSS, it is not very likely to be accepted in the Scopus publication, okay? Because, you know, just SPSS, but when I found the result that, the trending is really upwards, okay? So please don't be afraid to use the SPSS and publish in the Scopus journal, okay? They accepted. And in fact, even though many of you use the PLS, but some analysis, it is better analyze using the SPSS, okay?
Okay, Dr. Huda, one
Yeah.
question. Okay,
Uh-huh.
and let's say for Komograph or Shapiro, the test for
Okay.
normality, if the
Uh-huh.
significant value less than 0.05, that data can be accepted, right? Or boleh
Yes.
accepted. Tapi dalam
Yes.
tesis kena justify.
Yes, betul. For the Shapiro, it is different actually. For the Shapiro, it will be more than 0.05 is significance. Okay. Um, but again, you don't have to look at the normality test only. Okay, you have to also include your justification based on your charts and also plots, so that it will support your findings. Okay, for the normality test, usually you need to report charts and also normality test as well. Okay, not just one single statistical test, so that you have more tests to support your findings. Okay.
Okay, I think that's all for the Q&A session. If you have any more questions, you can directly email to Dr. Nurul Huda. Okay, I will share Dr. Huda emails at the chat box later. You can email her anytime to ask the question. Okay, so we are at the end of the session. So once again, I would like to thank Dr. Nurul Huda for your insightful and informative sharing session. And there is also a request from the participant to have more uh, advanced webinar after this regarding the SPSS and data analysis. So we will consider that and stay tuned for more webinars in the future, inshallah.
Sure.
Okay.
Can we
Once
have
again, okay. Okay. Lastly, can you fill in the link for the CPD and also for the recording and the slides later? I have shared the link in the chat. And we have a photo session?
Yeah, photo session.
Okay. Can you share your your screen? No, your video. Please
Yeah, turn on the webcam.
turn on the webcam. Dr. Ashraf, can you help to take the photo? Okay, in the count of 1, 2, 3. Okay, 1, 2. Okay, another one. 1, 2. Okay, I think that's all.
Thank you
Thank
so
you,
much.
everyone, and
Thank
have a
you.
nice rest and
Have a nice
have a
weekend to
nice
all.
weekend.
Bye. Thank you.
Bye bye,
Bye.
everyone.
Thank you.
Good night.
Ada usul main sebelah.